So here we go. Like I said, I think it's really important that you have detailed notes in this one. And I'll tell you, some of it's not that detailed when we get there. There was no vocab, which is good news. And number 10 is a beautiful example of how climate change is important, but I'm not sure that the science trivia is all that critical for the AP test per se. Polar bears are not dying because temperature is 1.5 degrees hotter. They like warm temperatures. In case anybody was unaware, polar bears are mammals. They have mammaries, fur, all that stuff. So they like warm weather. You put a polar bear in Hawaii, that's a happy polar bear. Except, why are the polar bears going extinct due to climate change? It's not the heat, it's
Like the ice.
that's right, the sea ice, and they can't find their prey because they don't stay on the ice rafts long enough, or they can't get out far enough into the ocean ice stuff. Okay. Politics here. I've heard a lot of climate deniers, and I'm going to use a lot of different terminology in this unit, but you all know what I mean when I say climate deniers, people who deny that humans are changing global climate. Okay. I've heard a lot of people say, oh, come on, it's 1 degree. Santa Barbara goes from 30 degrees to 105 degrees, what's 1 degree matter? And you know, if that average changes by 1 degree, it matters a whole lot. First of all, fun fact that many of you didn't know, our periods of ice ages are just about 2 to 3 degrees temperature change from the norm. From the coldest ice age to the greatest interglacial periods, that's just a few degrees of average span. So first of all, our planet is on a pretty fine razor's edge with temperature balance. Second of all, that thing with the polar bears, when you heat up the planet by 2 degrees, about 1.8 of those degrees are water change, not air temperature change. And sea ice forms in that water, so when the water's about 2 degrees hotter, look at me, it takes about 3 more weeks for the ice to form, and then it melts about 3 weeks earlier, and when you take 6 weeks off the ice period, that really cripples breastfeeding mama polar bears, so less of them successfully get to raise a cub before it's weaned. And populations decline because less mamas produce viable cubs after the first year. It's also a perfect example. You all realize that polar bears evolved to live in that environment over time. Climate has changed. Usually climate changes slower than evolution. It's a really valuable concept. Remember, if climate is changing a little bit, there's going to be winners and losers. The winners have more babies. Evolution keeps pace. What's unique about the present is temperature has never changed this fast in the known record of planetary temperatures. There is no way that we can find any evidence of climate ever changing faster than the last 40, 50, 70 years. So the polar bear thing is kind of a unique example, a key counter argument to the political issues. Okay. Anybody want to talk more polar bears? Anybody ever seen a polar bear? What is it? I've seen a few, and the happiest polar bear I ever saw was in Memphis, Tennessee. I've seen them in a couple different zoos. I've never seen them in the wild. Yeah, I've never seen them in the wild. But the one that I saw in Tennessee was like, the two I saw in Tennessee were like so happy. They're all like blubbery and greasy, like romping and playing. I was wearing trunks. Remember, it's not the heat that kills them. Okay, number 11. 1 star because you've got to know these facts. It's basically AP test trivia. So wherever you wrote them down, how many people wrote down the top? How many did you need? 5? 4? The 4 most common are nitrogen, oxygen, argon, and CO2. Is that right? Water vapor's not in there?
No.
There's what?
There's like more that's really good.
Got it, thank you. Okay. There's one thing I need to point out. I don't know how carefully you rounded your numbers, but roughly, just for the sake of conversation, please look up. Roughly the entire atmosphere has nothing to do with climate. Nitrogen gas on its own, oxygen gas on its own, and argon gas on its own have no direct impact on any part of the climate equation. So this is where climate denial meets science and can be used two different ways. Pay attention, this is a political issue based on a small science issue. I've heard people say, who cares about CO2? It's a teeny fraction of our atmosphere. I've heard people say, we're not adding a lot of CO2. We've added 0.015% of the atmosphere in CO2. That's not a lot. And do you understand that factually, numerically, that's accurate? But it's misleading, because please look up. This is the only one of that list which has any relationship to climate at all. And we've elevated those levels by about 50% change. So there's not a lot of people who go crazy and shoot kids in public school. It's a very small fraction of Americans, but God forbid we elevated that number by 50%, right? Remember, D part of the atmosphere, but that's the only part of the atmosphere that has a big impact on climate, and we are raising those numbers significantly. So. Okay. Number 12 is that diagram you drew, and I will trust that everybody already drew it. I think that's 23.1, is that right? There are 6 things that you may not have seen. I'd like to point them out to you. I numbered them on my notes. You can do whatever you want in your notes. Number 1, notice that our atmosphere has distinct layers, like a jawbreaker. That comes up a lot in this unit. It's not one atmosphere. We don't talk about it as a single thing. The rules are totally different. The rules are totally different when you go from one layer to the other layer to the other layer to the other layer. Everything you've experienced is tropospheric atmospherics. All of your life experience in the atmosphere only applies in the troposphere. You cannot survive in the stratosphere. And if I take you to the top of that graph, you'll die 6 different ways within a minute. I'm not kidding. The radiation will kill you, the cold will kill you, the absence of oxygen will kill you, the pressure drop will kill you. What happens when you die from these pressures? In that case, basically your blood vessels can't hold blood anymore. So you know when you barotrauma, when you bring up a rockfish from the bottom of the ocean to the surface and its guts come out of its mouth? You know what I'm talking about? I mean, I know. You ever seen the photographs of the rockfish with big old, like a tongue coming out of tongue? I pop out?
Yeah.
But by the way, your body probably wouldn't get to do that because it would already be frozen solid and it would be turning into dust from all the radiation. So anyway, 6 ways you can die before you get out of the atmosphere. Yeah.
The temperature is like somewhat decent at the ozone concentration above the stratus.
Yeah, it's just right below freezing. Yeah, you would still freeze to death, but
Could you not survive there if you got up there?
you know, if you had like some warm clothes and stuff, but you would already have died. Even if you could survive the journey, like if I could just like open the elevator up there, you would suffocate. you'd pass out pretty fast. You'd run out of oxygen almost immediately. The pressure change would cause hemorrhaging in a lot of your circulatory system. And the radiation at that point, you'd go blind, your skin would start to sizzle, you'd have a sunburn in like 4 minutes. Just the radiation alone would cause organ failure within days, and you could survive all the other stuff. Yeah.
How does the guy that jump out of the
He was wearing an astronaut suit.
And he didn't.
Full on astronaut suit.
He just went to like the top of the stratosphere.
Right. Yeah, 30,000 foot drop. He was at the bottom of the stratosphere. No, top of the stratosphere, 60,000?
Maybe like almost did that. But
Wow. I don't understand. Yes,
So what's the red ramen?
that's temperature profile. And we'll get to that because number 2 is what is the heat source for the Earth?
Sun.
Nope.
24.2 miles. The highest jump.
The guy's drop. Baumgartner, or whatever his name is.
Yeah, he was longer.
He didn't really skydive. I mean, it's pretty rad. Here's how he passed out on the way down. And I don't think it was anticipated. I don't know if it was part of his oxygen supply issue or something. Pressure shift, I don't know what happened. But for some reason he passed out.
he went into like a really gnarly tumble.
He what?
He went into like a really gnarly tumble and had to like recover it.
Oh, what?
Nope.
What? What?
So the other guy was the
Yes.
Does he have like adjust in some way?
The space station is like a very Earth-like capsule.
You know, he's not.
I can't imagine the rigors on the body of being in the space station for a year. I'm not qualified to answer your question. But something I can tell you that I don't know if thought about is that the space station has artificial atmospherics inside it. The space station is not in space. And so inside the space station there's a lot of things that are carefully attuned to help your body believe it's on Earth. So he's got radiation blockage, he's got a pretty normal gas mixture, he's got like ambient humidity, and I think they do have a little bit of gravity, maybe not, I don't know.
How does spacesuits not allow radiation?
I'm not smart enough for any of these interesting questions, but I am getting really sidetracked. They have sunblock, yes. High altitude wind, and I can explain what causes the jet stream if you'll let me please lecture on it. Okay. Back to number 2 on your list of 6 things. Our planet's heat source is not the sun. Our sun is the energy source, that's true. Does anybody know where I'm going with this?
Is the radiation from the sun?
Kind of. What? What? Something, the question of what?
Is there a heat source like the Earth itself, like thermal mass, and then bounces off the atmosphere?
Oh, kind of. Look, you all know this, but you say it wrong, and when you say it wrong, you don't get a point on the AP test. Conceptually, wake up to like the science detail, because I know what you meant. But you didn't say it right enough to be accurate at college level. The sun's really friggin' hot, but you gotta be right there to feel it. The lowest quality energy is heat. So the heat of the sun, which is extreme, travels a few feet above the surface of the sun, maybe a mile or something. It is hot, but we're way too far away to feel it. What does reach us from the sun? It's light. So all things which have mass absorb that energy and radiate it as heat. The source of our planet's heat is the surface, not the core. We're not talking about red hot magma. The center of the earth is really hot too, and that heat doesn't travel very far. What you are experiencing right now, our atmospheric heat, is the same idea as wearing a black sweater out in the sun, and you feel some of that heat from your black sweater in the sun coming onto your skin. How many of you know what I'm talking about? That's the heat we feel on the surface of the earth. Black sweater out in the sun. Light is absorbed, heat is radiated. Because look, if the sun was the heat source, going closer to the sun, we would get hotter, correct? If it was a heat source. But that's not the case. To answer Kai's question, look, going further off the ground, temperature drops because you're getting away from the heat source. The only reason it picks up again is because you're having more interaction with radiation from space before it drops off as you get close to the vacuum of space.
How come there's different temperatures?
What?
How come there's different temperatures then?
Where?
Like in different places?
Oh, you mean at the Earth's surface? Different amounts of radiation, different amounts of sunlight. You know, summer days are longer, so it's hotter. Winter days are shorter, so it's colder. And then there's the logistics of where you are on the planet and which way the air is moving. We might get to that another day. Next. Please notice up there that 90% of the atmosphere is right down here at the bottom of the lowest layer. The outer layers are practically empty. Why does the atmosphere get sucked down to the surface of the earth? Gravity. Gases still have mass, they are matter. So just like solids get kept on the surface by gravity, so do gases. So check out the other part of what I just said. Yes, 90% is sucked close to the surface. That also means that the little bit which escapes that 90% must be the lightest gases or the most volatile ones, the ones that escape gravity. Conceptually, that's really important. Please look up. Most of the atmosphere is right against the surface. You know, about half of all gases are in the bottom 3,000, 6,000 feet. You all realize that some gases settle? If there's a natural gas leak in your house, if you drop a match, it'll light at ground level. Are you aware of that? The heaviest gases are literally like at the surface of the earth. So there's just a few that escape above 3,000 feet, and just a very few that escape above 10,000 feet, and almost none that escape above 30,000 feet, and so on. The atmosphere is sorted by density of gases, or volatility of gases. Yeah, that's all number 3. Number 4, our atmosphere has something really special, and it confuses the heck out of my students. It's called ozone. Does anybody know the chemical formula for ozone? Watch me. Molecular oxygen, oxygen gas, ozone. O1, O2, O3. Molecular, gas, ozone. That is oxygen gas. That is one atom of oxygen, basically impossible on our planet. And O3 is ozone. Most of the ozone is kind of active, so look where it's mostly concentrated. The majority of ozone is way above us, where we want it, because down here it's toxic and it kills us. Up there, it's helpful, it's sunblock. It prevents radiation. You gotta know that. Ozone is toxic, so thank God we don't have a lot. But up in the stratosphere, it helps us because it blocks radiation. That was number 4. Number 5, there are different types of ultraviolet in those different parts of the atmosphere. We have UVA, UVB, and UVC. Thank God we get to live down here where only the UVA makes it. You'll need to know later, not now, you'll need it later in this unit, that those different ultraviolets are like red is a different wavelength than blue is a different wavelength than yellow. You guys all realize that, right? The different wavelengths of light make different colors in our eyeballs. Okay, different types of ultraviolet exist in space, but only one of those reaches us here on the surface. There's UVA, B, and C. We just have A down here. Yeah.
And why do sunscreens say that they have UVA and UVB protected?
A, because it's really crafty marketing. Separately, a teeny amount of B reaches the Earth's surface, and it's more likely to cause harm in you. The percentage of it which causes harm is greater. So if anything, you should worry about it more, even though there's only about 1% in our atmosphere at the Earth's surface. And I've seen glasses that say UVA, B, and C. That's a scam. Because you don't wear sunglasses in outer space and there's no UVC down here. It just sounds more fancier. Finally, the 6th thing, and then we're done looking at this, is water. Something really special about our planet and about our atmosphere is our temperature range on Earth includes vapor, liquid, and solid water. And that's actually, as it happens, a pretty remarkable characteristic of the Earth. The fact that our atmosphere can have liquid, solid, and vapor of water, that's actually a really weird thing. Our atmosphere does have ice in it. We call them icy clouds. Goodbye, children. Is anybody leaving the campus right now? You are? Will you go past the mailbox on your way off campus?
I can go.
I can't ask you to go off campus. I'm just wondering if anybody had already planned to. If you don't know of the mailbox, thank you for offering, but it's got to get in the mail today. Okay, where are you?
Where is it? Because I forgot I'm going home.
Can we stop that, please?
Yeah.